We're going to continue solving equations, and this time we're going to deal with fractions. Fractions, people hate fractions, but this is something we can learn, and it applies from now till the end of your math career. So let's go back and look at problem this. X over 2 equals 10. We are going to use the multiplication property of equality to multiply both sides by 2, and what that gives us is, now, again, I write it as 2 over 1 just to remind myself that it's a fraction. 2 divided by 2 is 1. 1x is just x. And on the right-hand side here, this is 20. Okay, very nice. Now, okay, we're still in this category where it's just multiplying by the 5 over 1 on both sides. Okay, this is still x plus 2 equals 35. Take away the 2, x equals 33. But I'm trying to build up here so you can start to see at some point in time this isn't going to work. Now, if you multiplied both sides by the 2, this is still a fraction. This one's going to be 2 over 5. Now this one would be 6. You could keep going, but you've created a problem that still has fractions. So what we're going to do, and really it's what we were doing here, is we're going to multiply by the common denominator. There are 3 fractions in this problem. You don't really see this one until I put the 1, but you've got a denominator of 2, a denominator of 5, and a denominator of 1. So what is the common denominator? That LCD is 10. So multiplying, we're using the multiplication property of equality. Multiply both sides by 10. Again, I write it as 10 over 1 because it makes more sense. Let's do it in green. Green's a nice bright color. Okay, now this is the whole side, and I'm going to sneak it in here, 10 over 1. That's the property of multiplication, and I'm allowed to do that. Now, this one simplifies, and you have 5x, okay? No fraction. Okay, now, what we're gonna do is we're gonna distribute, because we're allowed to, on the right-hand side. So oftentimes, I won't even show this step. I'll just go right to writing this as 10 over 1 times x over 5 plus 10 over 1 times 3 over 1. Well, that's just gonna be 30, but in the meantime, we'll leave it that way. Okay, now, this 5 goes into 10 2 times. 10 times 3 on top, and 5x. What we have now is an equation with no fractions. That's why it's called clearing the fractions. Okay, now we've got just a simple linear equation where we can subtract the 2x, divide the 3. I know I'm getting a little sloppy here, but you guys are with me. Okay, yes, you could just move stuff around and use your calculator, but I don't want you to do that. I really want you to practice clearing the fractions because that's the concept that carries to harder classes. Okay, what is the lowest common denominator? You have a 4, and a 2. The lowest common denominator in this case is 4. Okay, LCD 4. I'm going to multiply the left and the right, but really it is just every term. Okay, so now what I've done on this one is I skipped showing this step because I think it's conceptually it's there, but I really want you to see that you just multiply, well, it's this step that I skipped. You just multiply each term. Okay, so 4 divided into 4 is 1. That gives you 3 on the left. 4 divided into 4 is 1. That gives you negative 9. Now this one's a little different. 2 into 4 is 2, but you still have that negative 7 right there. Okay, now I'm going to cheat and just go like this, dot, 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 because you can finish that there. Okay. There are 4 fractions here. This is the one that you might miss, but make it a fraction. What is your LCD? Your LCD, 3, 5, and 15, because that 15, 3 is a multiple of it, and so is 5, so that will work. In green, multiply your LCD here here, here. That's a 1. Don't let me get away with that. Okay, now hopefully that's not too messy. I feel like it might be. Well, let's continue anyway. All right, 5 goes into 15 3 times, and I have 3x. 15 times 15, you can grab your calculator, but I think it's 225. 15 into 15 is 1, but 1 times 3 is just 3. I can see what kind of problem it's going to be. 3 goes into 15 5 times. You still need to multiply that 2. Okay, that's a little exclamation point right there. People might miss that. Okay, now I'm going to proceed. We're trying to get the terms on the same side. When oops, that one gets real faint when I go slow like that. When I subtract the 3x, what I have is negative 225 equals 10. Now, that is simply false. This means there's no solution. See, I just made this problem up on the fly, and I didn't see that coming. It just happens sometimes. All right,